Welcome to this online certification course on nonlinear structural analysis, theory and applications. I am Chinmoy Kolay. I am the instructor of this course, which will be offered in the next semester. My research focuses on understanding the behavior of structures under multiple hazards using nonlinear structural analysis and advanced experimental techniques, and developing structural components and systems for mitigating such hazards. With that, let us get started. So, the first question I want to ask, why nonlinear structural analysis? Before we even answer this question, let us talk about why linear structural analysis. Well, as you know that structures are always subjected to loads, right. Some of the loads act all the times, for example, gravity loads. Some loads which act for some finite duration of time, for example, earthquake load and wind load, right. Now, we analyze the structure to determine member forces, the internal forces and deflections at several points in the structures, so that we can design them accordingly. The objective is that the structures must carry the designed load without any failure during their service life. But the problem is, the structures do not behave linear elastically under all kinds of loads. For example, consider earthquake loads. The philosophy of earthquake resistant design is such that we do not design structures to remain linear elastic. Instead, we accept some controllable damage. But the seismic design of structures is based on linear structural analysis. Then the question is, if you would like to know how a structure behaves under a real earthquake shaking, linear analysis cannot give you a complete picture. Then we have to go for nonlinear structural analysis. This is just one example. Okay. There are many other examples. Let us not get into many more examples. Let us get into the course content. So, in this course, we will start by briefly reviewing the fundamental concepts of linear structural analysis, because if we do not understand linear structural analysis, we cannot really understand nonlinear structural analysis, right. So, we will briefly review it. Then we will talk about the direct stiffness method, we will develop for the linear structural analysis, and then we will introduce you to the nonlinear structural analysis, talk about the various sources of nonlinearities, how do we handle them, and then a significant part of this course will focus on the material nonlinearity. We will start at the very basic level of stress and strain, nonlinear stress strain relationship, and then we will look into several models of stress strain response. For example, models that are good for concrete, that are good for steel, masonry and so on. Okay. And we will then move on to the section analysis, and finally, to the beam column element. There are two approaches, one is based on the lumped plasticity, other one is based on the distributed plasticity. So, we will look into those under the material nonlinearity, and then we will study the theories of geometric nonlinearity, and we will get into nonlinear static analysis. In the field of earthquake engineering, it is also called pushover analysis, and we will look at nonlinear dynamic analysis, which is also called the response history analysis. As you know, nonlinear analysis cannot be done by hand. We need a computer program, right. So, in this course, we will use OpenSys, which is called Open System for Earthquake Engineering Simulation. It is a free and open source software. So, meaning that if you want, you can develop your own material model or algorithm and implement it in OpenSys. So, we will use OpenSys along with Google Colab, which is again free, and we will use Python. Now, to attend this course, you do not need to know Python, because we will go through several examples during this course. So, that will help you, learn all this three. Okay. So, what are the learning outcomes? The outcomes are the following. You will understand the importance of nonlinear structural analysis, what are the sources of nonlinearities, how do you model structures for nonlinear analysis, and then we will also learn static and dynamic analysis. You will be able to read and comprehend relevant research work in this field of nonlinear structural analysis, analyze and design laboratory experiment, evaluate performance of real world structures. Now, I want to mention here that the focus of this course is on the theory and applications. We are not getting into the implementation of the theories that we will be learning in this course. Okay. So, what are the prerequisites? Mechanics of solids, structural analysis, design of steel structure and design of reinforced concrete structures. So, who can attend this course? Final year undergraduate students, master students in structural engineering, PhD students in structural engineering, postdoctoral researchers and practicing engineers who are practicing in the field of structural engineering can get benefited from this course. With that, thank you and I look forward to seeing you in the next semester in the course. Thank you.